Hi, boys and girls. It's Miss Pacell. Today we are continuing our unit on interpreting and representing data. We are going to be looking at how describing trends can help analyze data on line graphs. So we're really going to be focusing in on using and understanding the vocabulary that is associated with line slope. We've touched on it a little bit the last couple of days, but we're really going to dig in today, and we're going to look at some authentic test questions, which requires you to really have an understanding of some of this line slope vocabulary to be able to answer the questions successfully. All right, your essential question for today: how can the slopes of the lines between the data points help you describe and analyze the data on a line graph? So how can those line slopes and understanding them help you understand the data? When we talk about trends in a line graph, we are actually referring to how the lines connect from one data point to another in the graph. So we're looking at the slope of the lines. And sometimes we don't look from line to line. We look at the whole graph and we try to describe the trend that goes on for the whole graph. So we'll see a couple of those coming up. All right, this page is going to go in your journal. I'm going to be taking this and making it for your math journal to put in on page 33. But what you have here is your associated vocabulary with line slopes. So we already know that if a line from one data point to the next is horizontal, we know that that data doesn't change. We know that it stays or remains constant. We could say it stays or remains steady. We could say it remains stable or it stays unchanged. Whoops. Well, we can take different verbs and different adjectives and we can really get descriptive with the slope vocabulary. So anything that is rising, any kind of increase where your data point on the right side is greater or higher than the data point on the left, you're looking at a rise, a jump, a growth. You're looking at the data climbing, you're looking at the data going up, you're looking at an increase in data, you're looking at the data soaring, different verbs. And if it decreases, if that data point on the right is less than the data point on the left, you're looking at a decrease. So the data is falling, or you might say there's a drop in data, or a decline, or a decrease, or the data is going down, or there's a plunge, or it plummets. All right. And then to make it even better with a descriptor, we can put those adverbs with it. So we might say if a line looks like this from two data points, we might say that it is increasing sharply or rapidly. Okay. Let's look at this in action. So here are some lines. And on the left are some statements, verbs with adverbs, and we want to see which ones describe the lines. So take a minute, number your scratch paper A to F, and jot down which of these phrases best describe the lines. Now, some of the lines have more than one phrase that describe it. Pause the video, work on that. All right, let's look at your answers. So the easiest one for me is this one, D. This is kind of going to be my starting point because this one is horizontal. We're moving from a data point here horizontally. So D is where it's going to remain constant or stay the same. So vocabulary that describes line D would be remain steady, stays the same. All right, moving up from it, we have an increase with line C, but it's not a big increase, it's slight. So let's find which phrases would work for this. So I'm going to go with it increases slightly or it goes up a little. All right, opposite of that would be E, but it's not increasing slightly, it's decreasing slightly. So you should have picked decreasing or decrease slightly or goes down slightly. All right, a bigger decrease, a steeper decrease is F. So this is to decrease sharply, or you might say the data drops sharply if you saw this kind of a line slope. Opposite of that would be B, which is an increase, but it's a sharp or a more rapid increase. So the vocabulary you could have picked for this is that let's see, I'm lost my sight. It increases sharply. That was the one you should have picked. And the last one, it goes up. Right here we have a peak. The data drops. The data increases. The data decreases. The data increases. Guys, fluctuate is the word we would put with this. The data fluctuates. We have a fluctuation in the data. All right, here are a couple different slope. Let's talk about these 6 different trends as shown by the slope of each line, and how could you use the descriptors that we just had on the previous slide. So take a look and see what's happening. All right, remember you're going from a point that would be here to a point on the right, here to here. This one, they're concerned about what you would say about the data that's located here. You're moving left to right, you're moving left to right, you're moving left to right. So pause the video, jot down some verbs with adverbs that you think could describe each one. You know what? There's several different answers, so as long as we have something very similar, we're in good shape. Here's my ideas. This line is a significant increase in data. Here we have a slight decrease. This right here is called a peak. The increase in data stops here and drops here, but this is called a peak. Here the data remains stable. Here we have a sharp drop in data. Here we have a gradual rise. Let me give you some more possible verb and adverb combinations. Here we have a rapid jump in data, a gradual decrease. Here the data is at the highest point. Here the data stays pretty much constant. Here is a steep decline. Here is a slight increase. So take a look at what you have and see if it works for what descriptors I've given you as possibilities. All right, now we're going to use some authentic test questions to see how understanding line slope and the vocabulary associated with the lines can help us interpret the data on the graphs. So here we have a graph that shows the speed of a car as it traveled over a 60-minute period. 0 minutes to 60 minutes on the x-axis, 0 miles per hour to 60 miles per hour on the y-axis. So the question is, what is the total amount of time that the car traveled at any constant speed? So here's that vocabulary, that slope vocabulary. Constant speed means you have a horizontal line where your 2 data points are connected, but we have that at 2 different places. So the total time would be an adding of these amounts. So from 0 minutes to 20 minutes, from 20 minutes to, 25 minutes to 40 minutes is a 15-minute constant speed. So when we add those 2 together, we get a total amount of time of 35 minutes traveling at a constant speed. So this case, you would pick C. If that wasn't what you were thinking, reread the question and look at that data. Here we go. A graph shows the change in temperature at an airport over 5 hours. So we're going from 6 a.m. to 11 a.m. We're starting at 40 degrees. The highest temperature is 54 degrees Fahrenheit. Let's talk about this little symbol right here. Usually we have right here from 0 degrees to 54, we should have the same increments, but we don't. There's a little bit of a difference. So let's talk about that. We go in increments from 40 to 42, 44, 46, 48, 50, 52, 54. So we have an increase of 2 degrees. All right, but what's going on here? This is a section that's been cut out. We're telling the readers, or we're looking at it, and what we notice is that there is no data between 0 degrees Fahrenheit and 39 degrees Fahrenheit. So instead of having a bunch of empty space on our graph, this symbol tells our people looking at the graph, or tells us if we're looking at a graph, that the data started at 40 degrees. That is acceptable. That's the only time that you can have different increments between your numbers on your y-axis. So between which two times did the greatest increase in temperature occur? Greatest increase to me would be indicative that we are going to have a steep line, increased line, where the right side's a lot higher than the left data point side. So I'm going to eyeball it, and I know it's not going to be between 10 and 11, so I can throw out choice D because that's a decrease. But when I look at these line slopes, here is the one that is the steepest and the longest. But we always back up with doing the math. So A, from 6 to 7 a.m., 2-degree difference, 40 to 42 degrees. 7 to 8, we move from 42 to 48, 6-degree difference. That works right now as the best choice. C is 9 a.m. to 10 a.m. We are moving from 50 degrees to 54 degrees. That is only a 4-degree temperature increase. So the greatest increase was what we saw with this longer, steeper line. Answer would be B. Number of rainy days each month in Springtown from the months of January to June. So here we want to find the true sentences, or which one is true out of the choices. The number of rainy days decreased each month. That is not true because of what happens here. And the word each month means between every month there has to be a decrease between every 2 months. So that's not true. Looking at it, we know that it's not going to be B. The number of rainy days do not increase each month. As a matter of fact, they only increase between March and April. All right, so it's going to be between C or D. So the number of rainy days decreased over the 6-month period versus the number of rainy days increased over the 6-month period. Remember at the beginning of the lesson, I said sometimes we're talking about the overall trend. So if you had to summarize what's going on, my summary would be that there is a trend of a decrease over this period. I know there's one small increase. That's the exception, but the overall trend is a decrease. The overall trend is not an increase. Our graph would be starting down here and ending up here. And yeah, we might have had a dip in rain between a 2-month period, or between 2 months, but the overall would be an increase. So this answer would be C. And this is where you're having to interpret the overall trend. All right, science experiment. We want to know for how many minutes of the experiment did the temperature stay the same? You guys know that slope vocabulary. That would be describing where the data didn't change. So from 0 to 35 minutes, from 0 degrees Celsius to 50, I see a constant 30-degree temperature reading between 15 and 20 minutes. That is a 5-minute span. Answer A. All right, here we have movie theater prices from 1960 to 2000. So between which years did the price of the movie ticket increase the least? Well, they increase between every 2 data points, but we're looking for the least increase. So think about your slope. A least increase would be a slight increase, wouldn't it? So it would not be a steep line. It would be a short line that would be closer to horizontal line. So let's take a look. Eyeballing it, I'm going with 1960 to 1970, but I definitely want to back it up with the math. So between 1960 and 1970, the ticket increases from $1 to $1.50. I know that's $1.50 because it's right in the middle of $1 and $2. 50-cent increase. Between 1970 and 1980, we're going from $1.50 to $2.50, so a $1 increase. So far, I'm right. From 1980 to 1990, that ticket jumps from $2.50 to $5. That is a steep increase. So that is a $2.50 increase. And from $5 to $6.50, a $1.50 increase. So we were right. I was right. The least increase was between 1960 and 1970. Answer choice A. All right, this graph, we're looking for a steady increase in the price of gas over a 4-month period. Guess what? I can look at that and tell you what it is. The only graph that matches a steady increase over a 4-month period is graph A. Starts at $0, goes up to, well, this data point would be 6, wouldn't it? Here it is a decrease, so that is a steady decrease. Here is a increase, but a fluctuation here, so that's not steady. Here it's constant. So steady increase of the price of gasoline over the past 4 months, right here it is. Your answer is A. All right, a soccer team recorded the number of goals they scored each month in May, as shown in the graph below. What statement best describes the information? Are the goals scored increased from week 1 to 4? Yes, there's a steady, or there is a constant, some kind of increase between every 2 data points. I'm thinking that's it. Let's make sure. More goals were scored in week 2 than in week 3. Nope, it's opposite. There were more in 3 than in 2. The team scored fewer than 4 goals in week 3. Right here it is, and to me it's halfway between 4 and 6. That's 5 goals, so that's not true. The team scored fewer than 10 goals in May. Well, let's add it up. 2, 4, that gives us 6. 5 more is 11. 6 more is 17. 17 is quite a bit more than 10. So, boys and girls, your answer is A. The goals scored increased from weeks 1 to 4. All right, here we have the probably my favorite one. We have to put a story with what's going on. So we have to understand that Sally is moving in a race. She's walking in a race. She has her time, 0 to 10 minutes, and this is how far she goes in meters. So what I see is she starts out, she's moving, not too fast. She speeds up here. Look at the slope of the line. In the same amount of time as between these data points, she covers more ground. She gets further in her distance in meters. So she's speeding up. What's happening here? These 2 minutes, she is taking a break. She's either sitting down, maybe she ran to the restroom, maybe she stopped at the water station. Then I see some acceleration. Between these minutes, she's going a further distance, so maybe she's doing some speed walking. So let's put a story with it. Sally started the race going very fast and then slowed down for a while. Then she finished the run alternating walking and running. That doesn't match. She didn't start out very fast and then slowed down, and didn't even talk about her break. So I'm not going with A right now. Sally started slowly, gained some speed, rested for a while, and finished the race at a quick pace. Wait a minute. Started slowly, sped up, rested, then finished at a quick pace. I'm thinking it's B. C. Sally ran most of the race at a steady pace, but slowed down at the end. No, we would have probably about the same slope of line between all the data points, and then it would even off a little bit at the end. So it's not going to be C. Sally walked at first, okay, then she ran for a while, and then she walked to the finish. It breaks up right here. It doesn't talk about her rest, and it doesn't talk about speeding up at a fast pace at the end. So the answer is B. She started slowly, she gained some speed here, she rested, then she finished quickly. All right, guys, by the end of this lesson, you should be able to answer today's essential question. How can the slopes of the lines between the data points help you describe and analyze the data on a line graph? You should be at that point if you were with me during those questions and felt like you understood those. You have some boom cards. I want you to do a good job on them. I am only asking you to answer your boom cards one time. I'm taking your first score through. I want you in the habit of doing your personal best the first time through. When you are working, you might need a scratch sheet of paper beside you to do a little bit of math. All right, have a good evening.